Good afternoon, everyone. This is the session on high-performance web applications. Before we get started, just want to take a quick survey. How many folks are building apps using a single-page framework? It's going to be impossible to see now, but okay, so a fair number of people. So you're in the right place. What we're going to do first is we're going to start off with some of the whys for single-page web apps. We're going to get into some techniques and get into some tools as we have time to talk about them. All right, this is fairly short, so we'll zip through some of this. But first, what I'd like to do is talk a little bit about why performance matters. Right? So a lot of people think that, yes, I need to have a performant website, and there are reasons for doing it, but the main reason is around the user experience. When we talk about a mobile web application, any kind of application, even if it's a native mobile application, website, whatever it may be, a good experience is a website that's very smooth, loads quickly. When the user interacts with it, they get very quick responses and other things like that. So what we like to do is focus around the user experience and provide the best possible user experience that we can. Another thing around this is nowadays when we build single-page apps, it's not just for the desktop. Right? A lot of people focus heavily on the desktop initially, and then they try to adapt their web application for mobile. But everyone probably knows that a mobile device is much slower than a desktop device. So that's something else we take into consideration when we're thinking about building for the web. Right? And one of the reasons why we're interested in making sure that our stuff runs well on the mobile web is because Google and Bing now both rank the page load and page preparedness time as part of their search results. So the faster your site loads and the faster it's ready in the JavaScript layer inside of a mobile web browser helps your overall Google search ranking. So if you're interested in search engine optimization for what you build, making sure that your application runs and loads faster and all your JavaScript is ready helps increase your search ranking. And so, but the key motif around this section of this presentation is that the user experience means everything. So a lot of people don't realize that, yes, you can do lots of low-level performance metrics to get a better idea of what you need to optimize. But at the end of the day, it's all about what the user actually perceives as your website performance. Right? So the one thing that we do around UX to help users, these are just some basic screenshots taken from iOS and Android, older versions of iOS and Android, but they still apply. So when we look at this first screenshot, you can see that it's saying it's loading, right? 28%, 56 out of 200, whatever. If we look at the second one, and this is one of my favorite ones, right? It says downloading. This might take a while, right? How long? Do I need to, should I go have a cup of coffee? Should I go to lunch? Or should I go to bed, right? Which one of those three things do I need to do for this thing to complete? So one of the things we like to do in our application is whenever we make the user wait for any significant amount of time, we like to tell them, this will take 30 seconds, or this will take 3 minutes, or go have lunch, or whatever it may be, right? So we want to make sure that we inform the user as to how long operations will take. And this is all around the user experience, right? We want to make sure we keep the user in the loop, we provide fast-acting websites, fast responsiveness. Now, the one thing when we talk about mobile web versus the desktop web is that the user expects the same amount of performance on a small device as they do on the desktop. So when we think of the desktop, for example, we think of a modern machine that has a lot of horsepower and other things like that, lots of RAM. But a mobile device obviously has maybe a 10th or a 20th of the amount of RAM and the amount of pure CPU and GPU horsepower. And in fact, what we see is that mobile users actually tune out faster on websites that they're looking at on their mobile device as opposed to the desktop. If you look at some of the numbers that have come out of people like Amazon and Google, they've done studies around this, and what they found is that generally speaking on the desktop, a user will wait around 7 to 8 seconds for something to happen once they've interacted with your web application. On a mobile device, when a user is using whether it's your app or a mobile website, that number is around 2 to 3 seconds. So not only are we dealing with a device that's much slower than what we have on the desktop, the user actually expects it to be 3 times more responsive on average. Okay? So these are numbers that you can Google and find, or do a web search for and find in terms of what folks expect from a mobile web experience. And obviously, when we're talking about mobile and mobile browsers, they have a smaller footprint in terms of the web apps and apps themselves. And also, the browser is slightly different than what you have on the desktop. For example, older versions of mobile Safari, going back to iOS 5 and iOS 6, only had approximately 100K component cache. And that component cache is essentially the amount of memory allocated to that web browser, that tab, to load in all of your JavaScript, load in your HTML, your CSS, and other assets like that. Not images, obviously, but HTML, CSS, and JavaScript. So the component cache is much smaller on a mobile web browser than it is on a desktop browser. On a desktop browser, a typical component cache is somewhere in the neighborhood of 1 to 5 megabytes in size. So you can see there's a large difference in terms of exactly how much stuff you can push onto a mobile web browser as opposed to a desktop web browser. And this makes a big difference in terms of how we architect and approach the building of applications that are supposed to work on both mobile and desktop. The other thing is that even though iOS and Android both use a WebKit-based browser engine, which is really good for us as developers because we don't have to worry about that third wheel, which is IE, or Internet Explorer, the browsers themselves between iOS and Android are very similar, but they're not exactly the same. And even between different versions of iOS and Android, the web browser gets updated. So when we think of targeting a mobile web browser, iOS and Android typically nowadays, yes, it's WebKit, so you have a lot of the CSS3 and HTML5 features inside of the web browser, but there are variations in terms of what feature level support there is based on how old the actual device's operating system is. So for example, Apple has been slowly adding OpenGL extensions to mobile Safari, which is available on iOS, but they've been slowly adding it as they've released iOS 7, 8, 8.01, 8.1, 8.3, etc. So it kind of changes over time. And the variance between the browsers can be something that can be problematic if you're not careful and you don't accommodate for that. All right, so the other thing that we tend to think about when we talk about performance for web applications is the network, right? Both for desktop and for mobile devices. So when we look at average network performance, right? So right now, this is average 4G speeds. This is in the US, obviously. These are the different carriers at the bottom: T-Mobile, AT&T, Verizon, Sprint, etc. But if you look at the average download and upload speed in this chart, you'll see that for most of these, we're getting at least, let's say, 5 Mbps, right? Which is pretty good, actually. Right? There was a time when 5 Mbps on a DSL line was pretty good, but now you can actually get this over a 4G network. And so both the download and the upload speed is actually pretty good. Okay? Now, when we look at the average 4G latency, however, this is where we run into problems. So the raw bandwidth that you get on a mobile network is actually quite good, but the latency is what's a problem. Right? So if you look at average 4G latency, let me move this up a little bit so you can see it. Right? You can see that we're getting somewhere 170, 150, 120, etc. So the latency time is actually quite high. Right? Does anyone want to guess what the latency on a wireless network at a large conference venue might be? What? Okay. So there's some decent answers in there, but even at a large venue like this, you can see that we're getting a latency to Google of about, I don't know, it's going to jump now because everyone will get on and try this, but it started off really good and it's deteriorating, but we're getting somewhere around 8 to 10, 16, 15 milliseconds latency. Okay, so you compare that, and you can see it's obviously spiking because it's a large network. But we're getting pretty good latency times from a wireless network. When I'm at my office in Atlanta, we have fiber, and when I plug in an Ethernet connection into our fiber gateway, I get an average latency of around 1 to 2 milliseconds. So it's very low, right? But over a typical wireless network, which is what most people use on their desktop computer, the latency is actually not bad, right? It's around, let's say, 8 to 20 milliseconds. But on a 4G network, that latency is much higher, right? So you can see it's 150, 120 milliseconds, somewhere in that range, right? So this makes a big difference in terms of how we architect our single-page web apps in terms of how we load assets and how quickly we should load them and how we should bundle them together and other things like that. So again, the speed is usually okay when we talk about a mobile network, right? Especially Wi-Fi network, speed is usually okay depending on which Wi-Fi you're using. It's latency that's the real killer, especially when the user's on a mobile web browser, on a 4G network or 3G. 3G networks have even worse latency times. Typical 3G latency is somewhere in the neighborhood of anywhere from 200 to 500 milliseconds. That's half a second in latency on a 3G network. Okay, so if your user is using data on a 4G network or 3G network, it's the latency that we really worry about because the speed is usually okay. You're probably not going to do something stupid and have a 5 megabyte background image that you're going to push to your user's mobile web browser, right? You'll optimize the image or use something small or do some browser detection and send the appropriate thing. But it's latency that we're worried about, and we'll see a couple of ways how to detect that and one specific technique for being able to accommodate for that as well. And again, when we talk about these raw network numbers and when we look at specific things in the browser in terms of figuring out how long it's taking to run certain operations within our web browser, we always have to focus on the user experience. Right? The numbers are great. Getting really high performance numbers are great. It proves that certain parts of your system work really well. But what does the user actually experience? Are they getting good responsiveness from every part of your application that they may use? So one thing that I like to show in terms of UX around this is if we look at, this is a slightly older example, but this is from an app called Instagram. It's an app you may have heard of or may have on your phone. But one of the things that they do to accommodate for the user experience and giving the user the best possible experience is if you look at this chart and we go from left to right, and let me zoom out here and center this on the screen a little bit, right? So when you take a picture in Instagram, when you're right here, make sure that looks okay, when you're right here, what they do is as soon as you take the picture and you hit this and you say, okay, it takes you to a screen that allows you to tag the, add some metadata. Basically, let's tag the picture. Say I'm here or, add other people or whatever it may be. So you spend a little bit of time doing that. Let me zoom back in properly on this. So you spend maybe a couple of seconds doing this, but by the time you finish and you hit the button to say, okay, the picture's already been uploaded, and all they have to do is attach the metadata, i.e. the tagging and other things that you've done, to that picture. So the user doesn't have to wait for the app to upload the picture. It's already been uploaded in the background, right? So this is one little UX trick which is kind of handy. But sometimes you have to think in different ways to approach the slow parts of your application and how do we make it better so that the user doesn't have to end up waiting, right? What are some little tips or tricks that we can do to do something like this? In this case, if the user comes here and they hit the cancel button, what they do with the picture that they've already uploaded to their server is they just throw it away. So they take the user back to the photo screen and they say, okay, the user doesn't want the picture, so go delete it off the server or whatever, right? So this is a nice little user experience trick, which is kind of different thinking in terms of how do we approach overall performance. The other thing around network is, are you loading multiple resources? And the answer will probably be yes. But another thing that's quite common today is to do something called code splitting, which is you take the JavaScript that you have for various different parts. Let's say you're using AngularJS or you're using React, and then you have jQuery and other things like that as part of your overall framework. You may also be loading in something like a ads engine, right? Some basically Google AdWords, let's say. And then you may also have other things for analytics, right? So if we use Google again as an example, you may be using Google Analytics, Google AdWords, or you may be using a different ad server, different analytics engine, right? But do you really need to take all that stuff that is something that the user is not really interested in? Because the user really is interested in the content that you're providing and the application that you're providing. They don't really care about the advertisements. They don't really care about the analytics or the performance beacon. What they're really interested in is the content. And a lot of people, what they do is they take the kind of easy route around this and they just bundle all of that together in one big JavaScript file. And then it has to read all that JavaScript. The browser has to read all that JavaScript. You get certain initialization that you do around that. But what's a common technique now is what's called code splitting, which You basically load your initial bundle of JavaScript first, show all the content, get the web app ready so the user can start interacting with it, and then you load your JavaScript for your advertisements, and then you load your JavaScript for your analytics and your performance beacon and other things like that. And what that allows you to do is the user gets the application or the web page ready as quickly as possible so they can start interacting with it, and then all the stuff that you're interested in as a developer gets pushed in, the advertisements, the analytics, and other things like that. Okay. So let's talk about browser performance for a few minutes, and we'll get into some tools after that. When we look at a typical browser update, there are three major phases that we have. We have, essentially, there's about 14 of these in total, depending on the web browser, but there are three major phases. You have the phase where we parse the markup and the CSS. You create a render tree from that. Okay, the render tree is essentially taking that parsed markup in CSS and converting it into native objects in the web browser, i.e. the render tree. That render tree is then used to actually draw the image on the web browser, right? So that is the reflow and repaint step of this. So you parse the markup in CSS that's there. A render tree gets created in the web browser. It's basically native browser objects that are native, not in JavaScript, but native in the web browser. And then those native objects are essentially the UI elements that get reflowed and repainted onto the actual browser window. Okay, so three major steps. There's 14 of these if you kind of break them down, depending on the browser, but there's three major steps here. Right? And if you do the reflow and repaint a lot, that's when you really hit a big performance hit in the web browser. The first two steps, they take some time, depending on the complexity of your markup and the complexity of your CSS. The first step can take some time. Second step, not as much time, but it does take a little time to take all that, transform it into native objects. But it's the third step, which is the reflow and repaint, which is the most expensive and the heaviest, and that is what the user normally perceives as the slugginess of your actual application, right? Some people call it jankiness or sluggishness in the web browser. So that's what we want to avoid doing, reflows and repaints. Right? So what are some typical things that will trigger a reflow and repaint in a web browser? Four major things. There can be others, but there are four major ones. Anytime you do a DOM update, obviously there's going to be a reflow and a repaint. If you hide a DOM node, reflow and repaint. You move or animate a DOM node, reflow and repaint. And just making a CSS change, doing a style change, will also trigger a reflow and repaint. So these are the four major things that you want to try to minimize. You can't avoid doing them, but you want to minimize them as much as possible. Okay? So when we talk about the overall kind of arc around how do we do these things within the browser itself, we typically think of ways that we can kind of bundle things together. And a bit later, I'll talk about some frameworks that actually handle the minimization of these four major things in a few minutes. Right? You probably have heard of these frameworks. Almost all the frameworks are starting to do this. But let's talk about tools for a few minutes and get back to what our discussion on code splitting was. So there's an excellent tool called Webpack, which is a modern tool which is essentially a module builder for your single-page web application, right? Or even just a website in general. Right? It's a module builder that essentially allows you to do a number of different things. It's suited for large projects. It allows you to do code splitting, which is what I talked about earlier already. And it also allows you to handle static assets. So you can do PNG crunch, for example, and other things. Allows you to also do various other things around, for example, if you use less or SAS, allows you to process those. So basically, it's an all-in-one tool that does everything you need to prepare either your website or your single-page web application for delivery to your end user. Now, we talked a little bit about code splitting, but let's get into that and what that really means. So code splitting allows you to take the assets that you have, specifically JavaScript, but not just JavaScript, specifically JavaScript, and allows you to do an incremental load of them. So what you can do is you can bundle everything. Say you're using AngularJS and maybe a couple of other JavaScript libraries, and then you have your JavaScript for your main web application there. It allows you to bundle just that portion together and say, okay, this is the first bundle we want to load in the initial load of our web app. And then after that, create a separate bundle for our Google AdWords or whatever it may be. And then let's create a third JavaScript bundle for analytics, performance beacons, and other things like that. So it allows you to do staged loading of your single-page web application inside of the web browser. Okay, it also allows you to do incremental loading of other resources. Okay, so the way it does this is it takes your large project and you tell it to say, okay, create a bundle from this, create a bundle from these resources, create a bundle from these, and then in your HTML you go and load those 3 bundles in the appropriate order. Right, you can have more than 3, just giving you an example of 3. Right? So when we look at a quick example of how code splitting works in action, right, so this is the CNN.com website. It's a news website in the US. The main content is here in the middle of the page. Right, but you can see here on the right there's an advertisement here, and this is more content right here. And if we went to the bottom, there'd be other things. Or if we open up the source, we would also see other things loading. Right? So to give you an idea how the code split actually works, if we go to CNN.com, and let me make sure I have Ghostery turned on. So I have blocking paused right now. So Ghostery is a plugin that allows you to control all of like the advertisements and other kind of things that you might want to block. Right? So DoubleClick is an ad engine, ClickTail is an analytics and behavior tracking and other things like that. So this is a nice tool because it allows you to look and see what's actually loading when we're firing up a website. So you'll see that this actually will get bigger and bigger, assuming that it keeps loading stuff. Right, let's try this again. We may have to pick another website. Right, so you can see that things are loading not all at once, but they kind of jump in at different portions of the app. Right, and the way that the loading happens here, as you can see, we have big screen here, and then there's more content, and then we'll get an advertisement here, and other things like that. Let's try a different website, actually. Let's pull up weather.com for my hometown, Atlanta. Okay? So if you watch this purple box here, you can see that not everything is getting loaded immediately. It's kind of coming in small, low stages. Right? So if we watch that again really quickly, make sure I have this turned on to proper appropriate level. And of course now the internet will run slow. But okay, right? So you saw initially just a small block came in, and then boom, and then boom. It looks like there's about 4 or 5 different stages in here. And we'll actually figure out what those stages are in just a minute. So I'll run it one more time. Okay, you can see initially, very small block, grows bigger, and then it grows bigger as other things load. Right there, the ads rolled in right there, and you saw those kind of jumped a little bit more. Okay? So just kind of when you're first testing your site out, this is a great tool just to get an idea of, hey, what's the stuff we're loading? How quickly is it loading? And again, that project is called Ghostery. It's a simple plugin for Google Chrome that allows you to get an idea of all the stuff that this page is loading. You can see that this page is actually loading quite a bit of stuff. Right? There's scorecard, advertising, more advertising, some analytics, et cetera, et cetera. So it's loading quite a bit of these things, and you can add other things that you want to keep track for it if you like. Right? But again, the tool is called Ghostery. It gives you a rough idea of kind of how all this stuff loads and what is it that you're loading in your website and how is it coming in. Right? If you're loading other performance beacons, or if you have users who may be using an ad blocker, if we turn blocking back on and then reload this page, you'll see that that box is much smaller because we've told Ghostery to stop loading all those advertisement and privacy things that we don't want necessarily everyone to see when we're using. Right? You can see that there's no ad fill now because we blocked the second stage loading of the JavaScript of that specific AdWords, or I think it was using Google AdWords engine. So if we pause the blocking, you'll see that at the very end here in the top bar, in just a second, the ad will load at the very last minute. Okay? All right, so let's go back to our slides, talk a little bit more about the implementation of code splitting. Right, so I've already shown kind of how this works in practice on commercial websites which are out there, but how can we apply this to what we do? And again, what Webpack is, it is a module builder. It allows you to do everything you need to do to take all your assets for your website or your single-page web application and produce whichever assets, transform the assets, whatever you need to do. Right? So you can see in this case, if we look on the left here, it will take, let's get this back in the view properly. Right, it'll take our less files, create CSS files if you use CoffeeScript. It will convert them to JavaScript, and it'll do all that stuff. And on top of that, once you have all that stuff ready, it will take it and package it into multiple bundles. It may run PNG crunch to reduce the size of your PNGs if you don't do those initially. So it can basically take all those things, produce multiple bundles that you can then load into the web browser. Right? So Webpack also supports a bunch of other stuff. One of the really great things that it supports is what's called browser sync. That allows you to, as you're building your single-page web application, as long as you have everything set up, it will detect that you've changed the source file. It'll rebuild the assets, and it'll push the assets, new assets, whether it's JavaScript, HTML, CSS, whatever. It'll push those assets live into the web browser, so it makes development run really, really fast. Right? So you basically, doing Angular or React.js, we use this with React. When you're building a React website, we have Webpack configured in the back. We make a change to a JavaScript source file or a React component. You save it, and instantly shows up in the web browser within a second or second and a half. So this is what is known as the browser sync feature of Webpack, right? But it has tons and tons of great features. All right, so we've talked about Webpack, and we have a duplicate of those slides. So we've talked about one tool so far. We've looked at a couple of other tools, and small tools, but one of the things that we obviously need to do is we need to be able to measure at some point what is the performance of our web application or even just our website. So there are a couple of handy tools for doing this. And the way that we approach this is we like to just do high-level measurements as opposed to low-level measurements and get an idea of where the large bottlenecks are so we get most bang for the buck as we're trying to debug and kind of figure out, why is our single-page web application running slow? Or what is it that we can do to make this run better? Right, so we start with high-level measurements. And there are a couple of nice tools for that. Specifically, Akamai Mobitest is good. And then there's also a project that's called speedgun.io. The second one you can actually integrate as part of a continuous integration or continual build process. So whenever someone checks something in or they want to do a build, you run Webpack, you get everything ready, and even if you don't run Webpack, you can still do this. Once you have all your assets and everything ready for your application, you can integrate Speedgun into your actual project so that every time you do a build, you get a nice graph that shows how long did everything take to load. What was the on-load time, right? So they hook into the low-level timing API and other things within the web browser to give you an idea of, as you build your web application, what is the kind of overall load performance of my site? Right, but let's look at Akamai Mobitest really quick. So I have it running already. I think I've already run it here. Right, what this is you basically come here and you tell it to go and load your website from a, let's see, we'll go try to run something real quick. Okay, you tell it to go run from a specific device. You have to sometimes wait in the queue if you're not the first one in line. But what it produces is, let's escape this. What it does is it gives you a screenshot and then gives you the average load time here at the top, what the average page size was. But the interesting thing about this is the waterfall chart. So if we zoom into the waterfall chart here, you'll see that I put in http cnn.com as the place I wanted to start. And the first thing it did right off the bat was it did a redirect from cnn.com to www.cnn.com. And that redirect took 172 milliseconds. Right? So this is something that we'd like to avoid. So instead of doing a redirect from cnn.com to www.cnn.com, or if we look at, I think weather.com does this. Right? So this is a different website. Let's look at this waterfall chart. right? So you can see what these guys do is that even though I was looking at this from a mobile browser, it didn't do the redirect. It basically did browser detection and negotiated the content it should send to this specific device without doing the redirect. And what that gives us and the user is that where the user spared this 172 millisecond redirect time. Again, remember we were saying on a mobile network, the latency is the one thing that's really bad. It's not necessarily the speed or the raw bandwidth. It's the latency going back to the server, doing a DNS request, and then actually pulling the website. So the user paid a penalty of 172 milliseconds because CNN.com is not doing browser detection and from the server sending the appropriate content. Right? If we go to see what weather.com does, you can see I punched this in here and it did send us, you can see it sent us a mobile optimized version of the website, but it didn't do that redirect, so the user did not have to pay a penalty of 100, 200 milliseconds to start loading the content. Okay? So let's go back to here and have a look at their waterfall diagram. If we look at it in the large, actually, we'll start here. You can see that they're loading a lot of simultaneous assets now. And then here at the end, there looks like there's a bunch of stuff loading. So let's see if this is still running. That's still in the test queue. So I was going to see if a second result came out differently. But you can see what they're doing is they're loading quite a few assets here. They have some JavaScripts, CSS, etc. But what we're interested in here is this part right here, where we have the actual resource load time. And where is it that we're hitting the waterfall? Right, so this green line that's right here, if we zoom in a little bit more, you can see there's a little bit of a green line here. That essentially, it gives us our staged kind of waterfall line for this specific website, okay? And if we were to look here and see, it looks like it's right about here that for this yellow line that we're seeing the page is actually ready. And we keep loading assets. They're loading quite a bit of assets, obviously, as you can see, okay? But you can see we kind of hit a second waterfall right about here, and this is where our double clicks, basically our ad engines and other things are loading when we go to this website. And if we keep scrolling down, we'll see another waterfall right about here where this blue line is. And here's some more Google AdWords, Motads, I think, which is an advertisement engine, and other things like that, right? So you get the idea of what the waterfall looks like. It basically loads some assets, and then we have some condition met in the web browser. Usually at the end of the first waterfall, the website is ready to be viewed, and then the second waterfall will show some advertisements being loaded, and the third waterfall may show other stuff being loaded like analytics or whatever. Right? So if we go have a look at the second one, you'll see this one looks slightly different. It looks like at weather.com, well, actually, let's look at their load time. So their load time was about 9 seconds, which seems a little bit on the high side, to be honest. Right? But this is running on an older device. Okay, but if we look here, you can see we hit a little bit of a waterfall right here. And we know we're still not ready because it looks like it's loading fonts here at this point. It's hitting the font Google APIs. If we keep scrolling down, we load a whole bunch more assets. It looks like they're using directives and controllers, so it might be an Angular website, right? We can actually go look and see what they bundle in there. Right? But you see, we're still loading stuff, still loading, and it looks like we hit preparedness or start getting some content being shown at the yellow line here. Right? So here's a quick example of waterfall diagram. Let's see if this is running. Nope, hasn't run yet. But hopefully you get an idea of kind of what you need to look for in that. You want to look for the waterfalls and see what resources are actually being loaded. All right? So along with that, to automate some of the loading of the stuff, we can use something like SpeedGun or PageSpeed, which you can just insert into your build process and say, once I've packaged everything and everything is ready to go, let's go run SpeedGun. Let's see how long it's taking since somebody made a commit or all these commits have happened. Have we done something to change the load time and the kind of overall initial load performance of our web application? Right? So I already showed Movitest. Let me show you another waterfall diagram. This is the kind of waterfall diagram that you want to have. Right? So if we were to go to m.weather.com, you would see that we get these two nice waterfalls. We're loading a small number of assets. Right, so this is kind of what we want to aim for rather than something that's really big like this, especially when we're running on a mobile site. We just want to bundle all the assets into a couple of JavaScript files or a few JavaScript files and then load them from there. Right, so just want to spend a few minutes talking about SpeedGun. I've already talked about it. It's something that you can just run from the command line. And what SpeedGun does is, again, something you want to integrate as part of your build process. And it runs Phantom.js underneath the hood. Phantom.js is essentially a headless web browser. So you have all your stuff ready. SpeedGun runs it inside of Phantom and takes low-level measurements to give you an idea of how long it's taking to load the assets, how long it's taking for all the JavaScript to initialize, other things like that. So it's a great way to see how your performance is over time. And so SpeedGun is something that you can run inside of your organization. It's not a service on the internet. So it's nice, you can just set it up. It's fairly easy to install and run. But when we look at something like PageSpeed, it does something similar, right? And gives you the size of your, basically your different assets and other things like that, right? The idea here is we want to integrate these kind of high-level performance tests on top of our unit test, our functional test, and other tests that we have as part of our overall application. Why not add in a web performance test on top of that to make sure that we're not doing something silly over time by adding a very large resource or not properly code splitting our stuff or whatever it may be. All right, so for a couple of minutes what I'd like to do is talk about next generation single page web app architecture. Right? And what you want to bear in mind is in this part is what we talked about a few minutes ago when we were looking at this diagram right here, right? This is how do we actually manage performance inside the web browser. We've talked about the network, we talked about how to do some measurements, we've talked about UX in general, user experience. How do we actually get to the point where we're ready to start thinking about how do we actually do a little bit of architectural things that can make a difference in terms of our performance and performance management in the browser itself. So one of those things that has been around for a little while now, maybe about 2 years, but is still gaining popularity is what's called isomorphic JavaScript web applications. And this is essentially that code can run either on the browser or on the server. That means you can take the same JavaScript code that would normally run in a web browser and do something similar to a render inside of the server and just send up that generated markup instead of trying to generate the markup on the browser. Okay? So what that kind of looks like is in a traditional web application, whether you're using Java or Ruby or Python or Node.js or whatever, your server has, make sure that looks okay, your server essentially gets everything ready and maybe it's just used to serve up the initial single page web application. And then, once Angular or React or whatever you're using initializes in the web browser takes over, and then the web browser just basically makes REST requests to go and get data and populate stuff inside of the browser. Right? That's what we think of as a traditional web application, specifically a traditional single-page web application. Right? So you have Angular, it initializes in the browser, and that's basically it. It just talks down to the server to get some data or whatever it needs to do stuff, but everything happens in the browser. So when we think of an isomorphic application, the line between the server and the browser is a little bit blurred. The idea here is that you have JavaScript code that you're normally running in the web browser, but let's run it down here on the server for certain parts of our application. Or maybe let's just render everything on the server. Whenever the user comes to the website first, we go ahead and we show them and we build out and essentially run the single page web application on the server rather than on the browser, so that we can do things like search engine optimization, we have more control over performance management and other things like that. Or we could say, all right, we want to run most of the app in the web browser. Again, we're talking about JavaScript apps, right? There's no Java or anything like that here. We want to run that all on the browser, but there might be a couple of portions which are extremely heavy or require a lot of data, so let's go run that on the server and just send up the constructed or generated HTML, which the framework will just plug in and be able to show very, very quickly, instead of having to essentially run business routines or UI routines to actually build stuff in the browser itself. Right? So again, the idea is that your code is It could be in the browser, or it could be on the server. And typically, people use Node.js. You can actually use the Java or JVM with the new version of the JavaScript runtime called Nashorn to be able to do these kinds of things. But most people use Node.js at this point in time. There are some good articles that I've seen where using the JVM and using Nashorn, you can run some of these same kind of isomorphic applications where the JavaScript runs in the JVM rather than on Node.js. Okay? So in terms of this architecture itself, what does it give you? It gives you a huge amount of flexibility in terms of performance management. There may be one part or several parts of your single-page web application that run slow. And if you want to remove that as a factor in the web browser, you can just have it run on the server, it's more or less exactly the same code that you would normally run in the browser, have it run on the server, generate the HTML and all the other stuff around it, and you just send up that HTML fragment and the framework plugs it into the browser for you. And whenever a web browser takes some markup, CSS, whatever, plugs it in, that is usually very, very fast because it's all done in one DOM node iteration or one DOM update. And it doesn't really have to think about what it really needs to do much, because web browsers are really good at taking static HTML and CSS and rendering it, right? If you think of what a web browser's main job is to grab web content, HTML and CSS, create the render tree from it, and show it as quickly as possible. All right. So there are a few things that help in terms of this isomorphic and kind of next generation frameworks. There's this concept of the virtual DOM, which has been around for a little while, but it's React.js that made it popular. So the virtual DOM is essentially a snapshot of the real DOM, and what that does is it mirrors the actual DOM that you have, i.e. what is actually being shown in the web browser. It's a mirror or a copy of that, but in JavaScript objects. And then the framework, for example, React, what it'll do is instead of manipulating the real DOM over here, it goes and manipulates the virtual DOM. So when you create React components and you instantiate them, you change the state of a React application, it needs to create new React instances of React components. It doesn't operate on the real DOM, it operates on the virtual DOM over here. And then the framework says, okay, it looks like we've went and refreshed the entire web application. I'm going to take that virtual DOM that I've changed, and in one operation, I'm going to apply all those changes, whether it's one change or whether it's 50 or 1,000 changes. It applies them all at once, so you only do one browser update. The other thing it does, which is in the second bullet here, is that it does a smart diff of the DOM. So we take a snapshot of the DOM over here, we operate on a copy of that virtual DOM snapshot over here, and then the framework overlays the two and says, okay, it looks like you've changed these 10 different things, but actually we only need to apply maybe 3 or 4 actual DOM updates. So it reduces the number of DOM updates and it only applies those into the actual DOM. So it's able to do a diff of what's actually there and what is actually changed, and just apply the changes that are necessary instead of trying to do a refresh of many things. Right? It can obviously also batch DOM updates. Okay, so when we also think of like other things we need to do, we eventually get to a point where we need to do some low-level analysis, right? And this is typically the last thing you do, right? As a developer, you want to, your instinct is, okay, let's just jump at the bottom layer and let's start debugging this in the web browser and let's see why this thing is slow, right? But again, what we like to do is we like to start high level. Let's take a high level performance measurement, get an idea of what's going on here, and then if we need to, go and dig down deeper and do a low level analysis, and typically we use something like Chrome DevTools to do it. And it has a lot of little things inside of it that allow you to see what is actually going on in your single page web application, right? And the main one that we use is what's called the timeline. Occasionally we may need to use the heap analyzer to see if we have a memory leak, but the timeline will also show that, right? For measuring CPU and memory utilization. And since we don't have a lot of time, I'm just going to jump into the example that we have. Okay, so I have a few examples, and let's clean this up a little bit. So I have essentially something that I'm loading here, which is the sessions for a conference, and I'm just putting them and rendering them into a web browser. And when I run this, you'll see here at the bottom, Chrome will actually start collecting the data. It'll go and do some instrumentation around that, and it'll give us an idea of what is happening when we load the application, or even as we interact with the application. The timeline will get extended, and it'll kind of collect those things and whatever, right? But let's do a quick analysis of this. Let's zoom in here towards the end, or towards the beginning, and let's just have a look at kind of what happens at the beginning of this web app. So if we scroll down here in the timeline, you can see that I'm using _JS. It took a little bit of time to evaluate, right, because it has to load the JavaScript. It has to get it ready, essentially create from the characters in this JavaScript file the JavaScript objects. All right, so we're doing a little bit loading, very, very small amount of time for around all this stuff, as you can see. Okay, we spent a fair amount of time parsing the HTML here. And then towards the end, you can see, if we zoom in here, we do paint and a composite, which is part of the paint process, and then a raster. The reflow will be here in here as well. Okay, but those are essentially the last few steps. Get everything ready, update the tree layers, and then do a reflow and repaint around the actual content of this application. So if we go look at the source real quick, not really doing much in the HTML itself at this point. We're just loading up our JavaScript. We have a couple of divs that we go insert some data into. And if we go look at how we're doing that, it's not too crazy. We have, I'm just loading a big JSON file that has all of the content that we're going to show inside of our web page. And so you can see it's just a big JSON file. Right, so here's the ID, here's the person, you know, there's their avatar, et cetera, okay? See, we have the abstract, this is the actual text that we're going to show, right, other things like that, right? So what we're doing in our JavaScript is we're essentially going in, and our data contains that JSON file that I showed. We're iterating over each one of them. We're creating a new entry where we're just doing some manual HTML construction in the browser, right? I didn't want to use a framework or anything for this. Just wanted to keep this as basic HTML, CSS, and JavaScript as possible. And so we go and we construct a new entry for each one of the things in our JSON, i.e. each one of the things in our list that we have here. And once we have that JavaScript or that HTML constructed, we go and get the element, and then we go and essentially do an append child to it so that it basically adds everything from top to bottom inside of this HTML file. Okay? You can't actually see it adding it because we have the instrumentation turned on and it's happening so rapidly. Okay, but if we go in here and pull up the next example, let me get my browser windows ready here. All right, let's run the next one really quickly. All right, so the major change that I've made this time here is that I've added some styling. You can see that I've changed the color of this, made it a little bit bigger. I basically added some styling. Specifically, what this one is doing is that it's importing the Bootstrap library, and I've added a little bit of styles. So we started with the really simple HTML, CSS. Now I'm going to add some styles into it. If we look at the JavaScript, it's exactly the same as before. We're just going through and creating those elements just by constructing the HTML like before. But the main difference is that we've created, we're using styles that we created, so that looks slightly different. Okay? So one thing to note here is that if we look here at this little blue area right here at the bottom, you can see that this is essentially our heap, or how much memory are we using. And we're doing a pretty good job here, because if you look at the overall heap, you can see we use a little bit of heap, then we go down. Right? So that's where JavaScript is doing a garbage collection. So we create all those objects, we're creating all those strings, right, for each one of the things, one of the entries that we have inside of our little list here, creating all that HTML, right, and then we're creating objects as we insert them one by one into our application, and our app is doing a garbage collection, so we can actually see what's happening here. Now if I move this around a little bit, and this is always difficult on a small screen like this, right? We can actually go look at the aggregated time as well around that we're spending. So if we go to our current example, we're spending about 60 milliseconds rendering and about 37 milliseconds painting, i.e. reflow and repaint. Okay, so for a total of about 100, let's say. Let me pull up the previous example where we didn't have the styles. Let's go run this. Do a reload so that we collect some fresh data. And you'll see that in this case, before we added the stylings, we weren't using a lot, maybe say about 80 something. But just adding the styles, let's run this one more time actually. This should be a little bit lower than that. The web browser might be doing something else because there's a lot of stuff. Right. So it looks like we're spending about, let's say, somewhere between 80 and 85 milliseconds to do the render and paint as part of this, just to get everything ready. Okay? So if we go back and we plug in our previous example, or our next example, to be specific. Sorry about that. Let's go run this again. So it looks like it's taken the measurements now. And if we go look, you can see that we've spent more time painting because we have more stuff here, right? So the paint time has jumped even though the render time is a little bit smaller. So let's go ahead and go to the next one. We'll see what that does in just a second. So you can see what I've done here is I've added more styling now, okay? So let's go have it run it one more time. Okay, let it take the measurements. We'll know the measurements are done by the little red dot that we have here. And now, if we go look at the render and paint time, you can see what's happened. The render and paint time is essentially almost tripled in this case, okay? We're spending quite a bit more time in the rendering and painting as we've added more complex CSS kind of styling around all this. The source for this is actually pretty much the same. Right, if we look at Lab 5, we're still incorporating our themes and everything. We're not really doing anything different in our source code except adding those things to it. Okay? So you can see that as we add more complex CSS, HTML, right, and the HTML here is really simple. If we were to have nested divs within nested divs within nested divs, or more complex elements, the render and the paint time goes up significantly. Okay, and one other thing that we've actually done, small thing I want to point out, let's do it on the next example here real quick, is let's go get Lab 6. Let's go refresh that, and let's have a look and see what we've done in lab number 6. Okay, so one thing that I've done here, which is not a good thing, is one optimization you might think of is, in the previous examples, what I was doing was going and doing a document.getElement by ID every time I wanted to add that element to the browser, or add to that specific location in the browser using append child. So you might think, hey, let's go ahead and let's cache that. Instead of grabbing it every time, let's just do this once, okay? And then we're also going to clear the element in between, you know, just to make sure as we add stuff to it. But what we've done in this case is because we don't release this main div here, and we're doing an assignment inside of a function, what we've actually done is if you look at the blue line here, i.e. the memory usage, you'll see that as we go from left to right, right, you can see that we never do a garbage collection. So what we've actually done by caching that node, that DOM element, and then not releasing it, is we've actually created a memory leak. Okay? So this is one thing you have to be careful about in terms of just memory management, is that if you go and cache a browser reference, i.e. a reference to a node element, make sure you release it at some point in time, otherwise you'll create a memory leak like so. Right? You can see our kind of render and painting time have still the same because we haven't changed what the actual screen looks like, but that's one thing we have to watch out for. All right, so let's get back to our slides. Actually, let's go just have a look at this. Yep, get back to our slides real quick. We only have a few minutes left, so We looked at the timeline. We looked at the low-level things we could do. Specifically, in this case, we were interested in the rendering and the painting performance that we have around our web app. We saw how it changed as we went and changed the styles, creating memory leaks and other things like that. Right? So you can measure the memory as well over time. What we don't want to see is something like this, which is the memory just keeps growing. What we want to see is the memory look like this. We use memory, garbage collection. Use some memory, garbage collection. If you're used to working in the JVM doing performance management, you probably recognize this as a sawtooth diagram, and that's what we want. Same thing in the JavaScript world in the web browser. All right? So you can also look at it for examining the startup time, which we did very quickly as well. And with that, I'm going to bypass some of the, you can go and grab the slides from the conference website, but I'm going to bypass some of the low-level things and try to get to the questions. Right? Where are the questions at? Is this it? Okay. Are we in the right place? Hopefully this works. We have a few minutes for questions, so I don't want to completely ignore them. Has this not been updated, the questions? No? Okay. Should we take questions or just move on? What's that? Oh, I'm overtime. The clock shows 3 minutes. So. Okay. Anyways, I'll just end it there then. If you have any questions, I'll be around today and tomorrow. I'll be happy to answer some questions for you. So thank you for coming. I hope you enjoyed the session.